Dear students, Assalamu alaikum and welcome to the third program on Software Engineering 1. In the previous program, we discussed what is a process and why do we need it. We also discussed that different process models have been proposed and they have different weaknesses and different strengths. One such model we discussed was the Waterfall Model. In today's program, we are going to continue with some more commonly used software processes, and we'll discuss their weaknesses and strengths. Dear students, let's look back again on the waterfall model and see one of the major problems with that model. As you can see from this diagram, the software process model, known as the waterfall model, is applicable only if the user knows its requirement at the beginning of the project. But for large projects, knowing all the user requirements is quite a difficult thing. Users generally do not have a complete idea that what type of services they would like to have in their software. Keeping in mind this weakness of the waterfall model was modified and a new waterfall model was proposed, which was coupled with prototyping. The proposed model is called the waterfall model with prototyping. Again, you can see from this diagram, the waterfall model with prototyping has the same steps, but it has been coupled with prototyping. Now, the prototyping is used at 3 different steps. Prototyping first helps the developer and the user to sit together and agree on the system requirements. Generally, when we use the prototyping during the requirement gathering stage, user and the developer sit together and they develop a small working system from whatever requirements are known to them. Then gradually, new requirements are gathered and accumulated so that a complete picture of all the requirement emerges out of it. Prototyping can also be used in the second stage of the waterfall model. As you can see from this diagram, that we use the prototyping with the second step, which is the system and software design. Using the prototyping model at the second step is very useful, especially for the designing of user interfaces, because now the actual users who will be using that software are sitting with the developer and defining exactly what type of user interfaces they would like to have. Prototyping can also be used to define other architectural aspects of the software. And the third step as well, the prototyping is also used when we do the implementation. During this step, prototyping helps the developer to test different algorithms for their efficiency. Using the prototype, the developer can make sure that the proposed software and the components will satisfy not only the functional requirements of the user, but it will also satisfy the performance requirement of the user. So prototyping is used basically during the first 3 stages of the waterfall model to remove that drawback of simplified waterfall model. Of course, the prototypes which are built during the first 3 stages of the waterfall model, they are thrown away. They are not generally used in the final product. Once we have gathered all the requirements, we have designed some of the units of our software and they are tested for their performance, then most part of the prototypes are discarded. Yes, some part of the prototype may be used in the final product, but generally, that's not the case. The developer, once he knows all the requirement, design the whole system from the scratch, and then he develops the whole software as a unit. And then the remaining steps are carried out. Dear students, we have seen that the prototyping model is very useful to collect the user requirements. It not only helps the developer to get the requirement and visualize the things the way the user would like to see, but it also involves the user in the development process. More involvement of the user means more success. There will be less chances of failure of a project. Similarly, looking at the benefits of the prototyping, the people have used the prototyping model alone to develop a complete software, as we'll see in our next model. These are the stages of prototyping model. In the prototyping model, we start with the abstract specification. We build a prototype. The prototype is given to the user so that they can use it, and we get their feedback. If they are satisfied with the prototype, then the software is ready and is delivered to the customer. If the prototype is not sufficient and it lacks some of the functionalities, then we get those functionalities from the user and rebuild our prototype or improve the prototype, and again we follow the steps. So we are in that cycle, and we leave that cycle when the prototype is complete and it delivers all the requirement to the user. Prototyping model, of course, can be used to build a complete software, but it has its own limitations. These limitations are: a prototyping model is appropriate for small or medium-sized interactive systems. We cannot use prototyping model for building very large or complex software, because the cycle which is there, we rotate around those 3 steps where we improve the prototype, we deliver it to the user, and then we get their feedback. In this case, if our software is quite big, and we might not be finishing it forever, and the product will not be even complete for a very, very long time. So when you are building a very huge system, a big system, then the prototyping model is not a suitable choice. Another observation about the waterfall model is development of part of a large system. As we have just mentioned in our previous model, that the waterfall model can be coupled with the prototyping model, and therefore the prototyping model can be used to build the part of a big software. For example, it is very useful to use the prototyping model to build the user interfaces. Also, prototyping model can be used for systems that have short lifetime. The reason for this is that the software which is built using prototyping model, they lack the quality. It's not well planned, the design might be faulty, and therefore you cannot maintain that software for a long period of time. So if you are developing a software which is going to be used for a short lifetime, then the prototyping model might be a good choice. Another observation about the waterfall model is the lack of process visibility. We have discussed before that a good model should be visible, that after completion of each stage, we should be knowing that how much work has been done and how much work is remaining. That's very important from the management point of view, so that they can control the budget and other constraints. But unfortunately, with the prototyping model, we cannot exactly know that how much work has been done and how much work is remaining. And therefore, we might not be able to control the project. Therefore, waterfall model is not that much visible as long as we keep working in the loop. Some other observation on the prototyping model are: developers often make implementation compromises. Systems are often poorly structured, and therefore they are difficult to maintain. And we might need some special skills to develop a prototype, because the purpose of prototype is basically to develop the system quickly, and that might need using some case tools. So the people who are developing the prototype, they should have the knowledge of using different case tools, and other programmers who are not too much familiar with the case tools might not be able to develop prototype quickly. The next model we are going to discuss is called the Rapid Application Development Model. The Rapid Application Development Model is an adaptation of the linear waterfall model, as we discussed before. But this model has been specifically designed to develop the business applications within very small amount of time. As you can see, the basic steps of RAD model, the first step is we do the business modeling. The next is data modeling, process modeling, application generation, testing, and turnover. You can see that we have mentioned on that diagram there are more than one teams working on the software, and each team follows the same steps. Dear students, the Rapid Application Development Model is very useful when you want to develop a business application. If the business application is a small one, then one team might be enough to develop the whole software. But if you are working on a business application which is bigger in size, then a very careful analysis of the whole system is required. You have to subdivide the system into subsystems and then assign each system and subsystem to one team working on the development of that subsystem only. Once all the subsystems have been developed, then they can be integrated together to make one application. Let's briefly discuss what are the activities we carry out during each step of the RAD model. During the first step, which is the business modeling, the developers and the system analyst, they study the system in its totality. They try to see what information is produced, who produces that information, who uses that information, and when that information is really used. Once we have an overall picture of the whole organization and its working, then using that knowledge, in the second step of the RAD model, we do what we call the data modeling. During the data modeling, we identify the entities, we identify their attributes, and we identify the relationship between entities so that we can store that required data in a database. Generally, this is done with the help of ER diagrams. Once the data modeling is complete, then we do the next step, which is the process modeling. In the process modeling, the analyst tries to establish that what type of processing has to take place inside our system to produce the required output. Generally, the different techniques are there which are used for process modeling, and one such technique is use of DFDs. Once we have the clear model, data model, and the process model, then the applications can be generated quickly using case tools and the reusable components. And a whole full working software is ready, which can be tested and given to the end users for use. Like other models, RAD model is also has weaknesses and some strengths. Let's look at some of the weaknesses and strengths of the RAD model. Rapid development of business application and high level of reuse is one of the strengths of RAD model. RAD model advocates that we should be reusing the components, whatever components are available, so that the business application can be developed quickly. We should also use the case tools, and the time is very important in the development of business application. The businesses which want to take the lead, sometimes they want to launch the application very quickly. So the developers are not given too much time, and they are required to develop the software in a very small amount of time. Another observation about the RAD model is, For large projects, RAD requires sufficient human resources. As we have seen in the diagram, that if you are working on a large system using RAD model, then you have to break your system into subsystems. And then each subsystem is developed by a separate team so that the whole system can be developed within time. But if you are going to make more than one teams, you need people. Otherwise, this software could not be completed. Acquiring well-qualified staff to develop an application is quite difficult. Therefore, the RAD model needs that you should have sufficient human resources if you are using that model to develop a large software. Another observation about the RAD model is lack of commitment results in project's failure when you want to develop an application quickly. A lot of resources are required, the human resources and the other computing resources. If the management is not committed to provide those resources, of course, you will not be able to complete the project within time, and hence the failure of the project will result. Another observation about the RAD model is it is not appropriate when technical risks are high. And another one is that RAD model is not appropriate for all types of application. That's very evident from the diagram we shown you. The RAD model has been developed basically for the development of business application. Therefore, if you want to develop other kind of application, the RAD model might not be a good choice. Dear students, all the model we have discussed so far, they develop the software as a one big chunk at the end. During the rest of the phases, we produce some kind of documentation, but a working software is not available until late of the project life cycle. This approach, of course, is suitable for some of the projects, but not all the projects can be developed like that. Sometimes we need a project to be developed and then it is continuously improved upon. Keeping that requirement in mind, many different models have been proposed, and generally they come under the category of incremental models or the evolutionary models. We are going to discuss 3 such models. The first model is called the incremental model. The incremental model basically again is an adaptation of the simple waterfall model. We test the software and we deliver it. And then we repeat that process for each increment of the software. The application of this incremental model is very evident in most of the commercial softwares. If you want to develop a word processor, we can develop the first increment or the first version of the software, which only provides the basic functionalities of word processing. For example, editing, changing the fonts and printing and things like that. And rest of the functionalities can be left out in the first version. The first version is delivered to the customer, we get their feedback, we get new requirements, and then we start working on the new version of the software. The new version might improve some of the functionalities of the old version. We can put some more functionalities into the software. For example, now we can put a spell check in our word processing software, and we deliver the second version of the software. And with each new version of the software, some functionalities are improved and some new functionalities are incorporated into the previous version. And once the software grows and grows, and ultimately we get a software which provides almost all the required functionalities. Dear students, this model also has some good points and some bad points in it. The incremental model is particularly useful when staffing is unavailable for a complete implementation within time. For example, if a business wants to develop a complete big software and they do not have enough resources, then they can start developing a core product which provides the basic functionalities. And with time, they can improve upon the system with limited resources. Another observation about the model is early increments can be implemented with fewer people, and increments can be planned to manage technical risks. The last benefit of this model is very important. If you develop a software and you put that software into use and then you find out that it's not worth working with that software, or the software is not accepted by the user, then you can minimize the risk of spending a lot of money and time on developing a software which might be a failure. Dear students, another evolutionary model is what we call the spiral model. Spiral model again works in stages and where the software is developed in increments. It is divided into what we call the quadrants. We start with the first version of the software with customer communication. We do the planning, risk analysis, we engineer the software, we release the software, give it to the customer and get the customer feedback, and then carry on with the next version or next spiral of the model. Dear students, during these steps, the first step is very important, which is the customer communication. Like all other models, you cannot build a software until you have the user requirements. So the first step has to be that you have to communicate with the users, get their requirements, get their feedback, ask them what really they want. Whatever requirements you get in an iteration, you do the planning. You decide whether we should be developing that part of the software or not. And if this software is to be developed, then how it should be developed. Once we decide about the planning of the software, then we should do the risk management. Note that this is the only model which specifically asks us to do the risk analysis. Whenever we develop a software, there are many types of risks which are involved there, which can result into the failure of a project. So a project manager has to evaluate the risks. He should see that if we go with that project, are there risks of failure? Then if they are, then how much risks are there and what type of risks are there? And how we can avoid those risks or how we can minimize those risks. So he has a complete risk plan with him. Once we have done the risk plan and we decide to go ahead with the project, then of course we do the designing of the software. Again, a simple waterfall model or any other model can be used for that purpose. We do the construction, we actually build this software, we test this software, and we release the first version of the software and give it to the customer. We get their feedback, and then we continue with the next spiral of the model. Dear students, spiral model also has some good points and some weak points in it. The spiral model is a realistic approach to the development of large-scale systems. You will appreciate the first point if you know the little history of the spiral model. It is the Ministry of Defense of USA which was suffering the problem of a lot of projects going failed. So they were working on different ideas that how can we improve the success rate of their projects. Most of the projects were very complex. They were very large in size. So they come up with the idea of the spiral model, that the software should not be built as one big unit, but it should be developed incrementally so that the risk can be minimized. So spiral model is a very realistic approach if you are working on a large-scale system. It tries to eliminate errors early in the phases. Another one is it works good for complex, dynamic, and innovative projects, as we just said. But the major problem with this model is that it lacks the direction, it lacks the explicit guidelines that how different phases should be carried out, how the risk analysis should really be done. Therefore, there are many different organizations which are using this spiral model or the modified form of the spiral model, but they have done very elaborate analysis of the model, and they have done a lot of elaboration of different stages. They have decided, they have outlined that how different phases should be carried out. But the original model doesn't speak too much about the methodologies which has to be used at different phases of the spiral model. Another observation about the spiral model is it demands a direct consideration of technical risk at all stages of the project. The project manager must be in a clear picture that during the development of the next phase or during the next iteration, what risks can be there, how they can be avoided. So in that context, the spiral model is very useful. Another model, which is again based on the incremental approach, is called the component-based development model. And the component-based development model, again we have the spiral model, but during the engineering phase, we follow these steps. The rest of the steps are similar to the spiral model. It's only the engineering phase which requires us to follow these steps. And the first step, we identify candidate classes. We look up classes in libraries. We extract the classes if they are available. If the classes we need are not available, then they are engineered using a waterfall model approach or any other approach. Then the new developed classes are put into the library, and we continue with the next iteration of the model. This model is very useful if you are using the object-oriented technology, which advocates for the reuse. That if you want to develop a product, look for what is already available. Look for the components. So if the components are available, just use them. If the components you are looking for are not available, of course you have no choice but to develop those components, and hopefully the new components might be used in some other product. This model also has some weak and some strong points, as we'll see now. The component-based model is suitable for object-oriented software development, as I just said. Component-based development model leads to software reuse, which is the basic philosophy of object-oriented software development. But the problem is that the lack of rich library of reusable component is not available to us. I recommend you to look around for some of these software systems and then try to find out the most suitable model for the development of that system. But don't forget to give the reasons that why a particular model has to be used for development of that particular product. With this, we come to the end of our third program. See you in the next program. Khuda Hafiz.